everyone. So today we're going to be doing lesson 7.4 on simulations using Excel and relative frequency distributions. We have two big problems that we're going to do and explorations in this lesson. I have the notes up here, and I'm going to be switching between the notes that you guys can print if you'd like and an Excel spreadsheet. This is where we'll be doing most of our work. We are going to learn two new Excel functions today, randbetween and countif. And so here I have space for you to write your notes on the commands if you need to do that. So in the first problem, we're going to look at rolling two fair die. We've done this several times, but it's a good one. So suppose two fair die are rolled. What is the likelihood that the sum of the two die is a 7? So we are going to run a simulation, let me go back here, with 10,000 trials or rolls in Microsoft Excel. And that seems kind of crazy if you can imagine taking two dice and rolling them 10,000 times to take you a long time. With Excel, we're going to be able to do this pretty quickly. So what I'm going to do in here, I'm going to write the trial number here, and I'm going to generate a list from 1 to 10,000. So remember the old school way. I can type in 1, and I can say equals, the previous number plus 1. And then I can drag this down, but I would be dragging for such a long time. It would be terrible. So I'm actually going to go back and show you a new way. Shout out to Charles from C Block who showed this to me. So I'm going to type in a 1. You always have to have your starting number and make sure you're in this cell. Then I'm going to go over here where you see it says fill. I'm going to fill in a series in the column, and it's going to grow linearly, going up by a fixed amount, a common difference, step value of 1. So this is saying it's going to go up by 1 until it stops at 10,000. So make sure it goes column, not row, because you want it to go down through column A. Linear growth, step value, you want it to increase by 1 every time and stop at 10,000. Hit OK, and there is your list. And you can see if you go here to, it's in A2 now, if you go to A, 10,001, you can see there is the 10,000. And remember, it's the 10,001 because you have your title in there. So let's go back to A1, back up here to my top. So let's let column B be roll 1 and C be roll 2. So I want this to just be the result of that first roll. So this is where I'm going to use the randbetween. So I know when I roll a dice, I can get a number 1 through 6. So what I want Excel to do is I want it to pick a random number between 1 and 6 to be my first roll. So I say equals randbetween, start my parentheses. I want it to be between 1, 6. End your parentheses and hit enter. And look, my first roll was a 4. So let's take a look and see. We're going to do the same thing. Roll the dice again. It's randbetween, 1, 6. In your parentheses and hit enter. Oh, now I got a 6. Notice that this 4 changed to a 6. Since these are random numbers, every time I kind of hit enter, essentially, I'm going to get new rolls. So now all I need to do is I need to go and fill this in. This is another new trick. Instead of dragging this, take these two things that you want to fill down, go down here until your cursor turns into the little black cross, and just take one finger and double tap on a Mac, and it fills all of this in. So now I have just rolled the dice 10,000 times. That happened seamlessly, like within 2 minutes. It's pretty crazy. Sorry for the sizzling. I'm in the middle of cooking dinner for the kids. So have to multitask here. All right, so here in column D, let's let column D be my sum of my two dice rolls, because that's what I'm really interested in. I want to know when the sum is 7. So in order to find what the sum is, I'm going to say equals B2 plus C2, hit enter, and again I can drag this down or use my new trick and fill this in. Again, the trick was I'm just going to be able to do, let me go back. Go make this cross black, and then I'm just going to take one finger, double tap, and it fills it down. Excellent. So I want to know how often I get a sum of 7. How often does this column give me a 7? I can see here I've got 1, 2, 3, 4, 5. I mean, I'm certainly not going to go count all through the 10,000 trials. So this is where countif is going to come in play. So sum of 7. So I can say equals countif, and then you can see when you start your parentheses, it gives you a little hint here. It says range and criteria. Well, my range is just all of column D. I want it to look at every single cell in column D. So I'm going to grab all the column, and to do that, make sure you grab from up here, comma, 7. So if it sees a 7, it's going to tell me. And there we go. We can see it happens 1,616 times. Remember, every time I kind of double click off to the side, I'm going to get new roles, and so it might change a little bit. But there it is. That's how often it happens. It says determine the relative frequency of the sum being 7. So for the relative frequency, I would have to take the number of times that the 7 comes up as the sum and divide that by the number of trials, which is 10,000. So there's the relative frequency. It is 16.73%. All right. I'm interested in how close is our simulation's relative frequency to the probability. So in the probability, let's see if I can change this a little bit. Let's circle all the times I get a sum of 7. So here's a sum of 7. Right here. Let's change the color. Red. Okay. So there's a sum of 7. We have another one here. Another one here. All through this diagonal, we get a sum of 7. So 6 total times out of the 36 total outcomes that I know are possible. So over here, if I want to compare my relative frequency to the probability, I would say that is equal to 6 divided by the 36. And I can see these two numbers are actually not too far off. And if I click, look, I'm clicking. It's really hovering like right around that 16%. I've seen it go up to 17% once, but it's really chilling right around that 16%, really close to the actual probability. So our simulation did a really good job. All right, so relative frequency distributions, you guys have seen these before, but we haven't done them in Excel yet. So what I want to do is I want to consider all the possible outcomes of this event, and I want to generate a relative frequency distribution. So to do that, I need to have all possible outcomes outlined. So when I roll these two dice, I could get a 2, or a 3, or a 4, or a 5, 6, 7, 8, 9, 10, 11, or a 12. Those are all my outcomes. I can then calculate the frequency and the relative frequencies of each of these outcomes. So frequency, in order to count how many times a 2 appeared, I'm going to have to use my new countif function. I'm going to countif here in D, the whole column. I see a 2 and see how often that happens. And what I think I'll do is I think I will, let's see if this works. If I drag this down and just change this formula, I just need to change here the 2 to a 3. And then I'll change the 2 to a 4. Or you can type them in if you want. It's up to you. Change the 2 to a 6, 7, 8, 9, 10, 11, 12. All right. And now for relative frequency, I have to take, it's just going to be equal to whatever the frequency is, divided by 10,000. And this one I can just drag it down because it'll roll and the 10,000 will stay. So there you can see your relative frequency chart right here. Maybe even make it fancy, give it borders. Probably need to make this one a little bigger. So here you can see you've got about a little under a 3% chance of getting a 2, 5.5% of getting a 3, Then you get an 8.6% chance of getting a 4, almost 11% of getting a 5, almost 14 of getting a 6, 16 of getting a 7. And then look at how interesting this is. You can see the parallels between rolling a 6 and an 8, and of rolling a 5 and a 9, of rolling a 4 and a 10, a 3 and an 11, and a 2 and a 12. You can see how those parallel each other, which should not be surprising given all of our outcomes listed here, because you can see that you can get a 2 once, you can get a 12 once, you can get a 3 twice, you can get an 11 twice. We're just looking at those diagonals. All right. So congratulations, you've run your first simulation and you've done your first relative frequency distribution in Excel. So now what I want you to do as an assignment on your own, from your simulation, if you're following along in the notes, you don't have to be following along in your notes if you're keeping all of this electronically. I want you to copy over your results here into your notes. And remember, if it doesn't match exactly, if you come over and double click, if it doesn't match later on, that's okay. It's because all of your results can change as you are double clicking over here. Then what I want you to do is I want you to do a probability distribution, and this is going to be from all of your outcomes here, the 36 possible outcomes. And that way you can compare the probabilities to your relative frequency distribution, and you're going to see that this simulation of 10,000 did a really good job of estimating these probabilities. So the results would be the same. The frequencies you're going to grab from your chart of 36 outcomes, and probabilities you can calculate in Excel or with a calculator. All right, so now we are on to the next simulation. Suppose a couple decides to have 3 children. Assuming there are no multiple births, what is the likelihood that the couple will have 0 boys, 1 boy, 2 boys, or 3 boys? We are going to run a simulation with 10,000 trials again in Microsoft Excel, and we are going to create a relative frequency distribution at the end that outlines all of the outcomes for us. 1 minute. All right, so let's go to a new page. Now we're still going to do 10,000 trials again, so let's go ahead and set that part up. If you want to pause the video now and do that on your own, that would be a good practice. If you didn't quite get it from the last time and you want to follow along, that's fine too. So we'll do trial number here in cell A1. We have to get it started, so we're going to type in a 1 and make sure we go back to that cell and that we're in cell A2. We're going to go to fill, in a series, columns, linear, step value of 1, going all the way to 10,000, and hit enter. All right, so now what we're going to do is consider they're going to have 3 children. So they're going to have child 1, child 2, child 3. I want to know what is the likelihood of having 0 boys, 1 boy, 2 boy, or 3 boy. So now this one's a little different because when I was rolling the dice, my outcomes were numbers, and so that was easy. Because Excel is only really going to be able to give me a random number between 2 integers, I have to decide what integers I want to use. It really doesn't matter, but you can make your life a lot easier by choosing numbers that are easy. So what I'm going to do is I'm going to let a boy be equal to a 1 and a girl be equal to a 0. So here for child 1, I'm going to say equals rand between 0, 1. It'll give me a random number between 0 and 1. Congratulations, it is a girl. Child 2, same thing. Rand between 0 and 1, it's a boy. Child 3 equals rand between 0, 1, and third child is a boy. And notice now my first child changed. So now I've got a boy, a girl, and then a boy. Let's go ahead and let's fill this in for all 10,000. There they are. So now what I want to do is in each trial, I want to figure out how many boys there are. So here I can see in this first trial there are 0 boys. Oh, but now it changed. Now there's one boy. Oh, now it changed. Now there's two boys. This is not going to work. I am not going to be able to go through and count. I mean, I wouldn't want to count 10,000 times anyways. So let's think of it this way. If I add up here these three numbers, I would get a 1. I see one boy. If I add these up, I see 1. I have a boy. Add these up, 0 plus 1 plus 1, 1 boy. 0 plus 0 plus 0, we'll get a 0, 0 boys. 1 plus 1 plus 1 is a 3, 3 boys. 0 plus 1 plus 1 is 2, 2 boys. This was very strategic to make the boy the 1 and the girl the 0, because that way I can just add them up. I can say this is equal to, since I did just normal plus signs, I'll use the sum formula this time. So the sum of these three cells. And when I do that, I'll be able to see the number of boys I have in each trial. And now I can just fill that down. So there we go. Now I know how many boys I have in all 10,000 trials. If you had decided that you wanted to make the girl be the 1 and the boy be 0, you can do that. That's totally fine. But then you would be adding up the number of girls. So you'd have to have another column and take 3 minus the number of girls to know the number of boys. There's no problem. No problem with that. All right, so now let's go ahead and make our relative frequency distribution. So I need to know all my outcomes, all the possible outcomes, and that would be 0 boys, 1 boy, 2 boys, or 3 boys. I need to calculate the frequency of all of these outcomes, and then I need to do the relative frequency. So frequency, I'm going to have to use the countif formula. So I want to count if my range is going to be all of column E, comma, 0. If I see a 0, that means I had 0 boys. 1,294 times there were 0 boys. For the next one, 1 boy equals countif. E, I see a 1. 3,776 times there was 1 boy. I need to do this 2 more times for 2 boys and for 3 boys. And then for relative frequency, I just need to take the number of times it happens divided by the total number of trials. And then I can drag this down. All right, so there we go. We can see it's about 12.5% chance of having no boys, 37.4% chance of 1 boy, 37.6% chance of having 2 boys, and then a 12.43% chance of having 3 boys based on my simulation. Not too bad. So here you can calculate your results here in Excel and then transfer them over to your notes. And then we want to know how close does our simulation match our probability. I think this is going to be a little hard for me to do without being able to write on this, but actually I think we can give it a go. So what we can do, I think a chart is going to be really cumbersome here. I think I want to do like a tree diagram. So I'm going to have 3 children, right? Child 1, 2, and 3. All right, so the first child, it can be a boy or it can be a girl, right? And now child 2, I mean, it could also be a boy or a girl. So kind of let's look at how this chart is looking. So it could be, so far, after I have 2 children, it could be a boy boy or a boy girl, or a girl boy or a girl girl. Those are my 4 options for having 2 children. But then I'm going to have another one. So I could have a boy or a girl again. Let's make this a little easier. Let's take these 2 and group them. And then I can copy and paste. So I could have a boy or a girl, boy or a girl, boy or a girl, or a boy or a girl. I should be able to see all 8 outcomes here pretty easily now. And I know there's 8 outcomes for having 3 children if we're assuming there's no multiples and we're assuming that, well, I guess we're assuming a lot. We're assuming that we only have 2 gender identities, first of all, so, and not unisex. So I'm assuming a lot here. But for the simulation's sake, I've got boy, 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 girl, boy, girl, boy, boy, girl, girl. I could have girl, boy, boy, girl, boy, girl, 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 boy, girl, girl, girl. So 8 different outcomes. So now that you have that in your notes, you can now look at your probabilities too of having 0 boys, 1 boys, 2 boys, or 3 boys, and calculate the frequencies and the probabilities, and then match them with your simulation and see how good your simulation did. We're not going to have a traditional problem set for lesson 7.4. We're going to have a project and a presentation on layoffs. And so once we have the next class, I'll explain that to you, and we're going to have probably 2 to 3 class periods to work on that, and I think you're going to enjoy it. Can't figure out how to stop this.